The wind clawed across the frozen ground as if trying to push every living thing back where it came from. In that hostile whiteness, a small tracked carrier skimmed over snowdrifts that swallowed jeeps whole. Crews clung to it not out of comfort, but because nothing else could move with such improbable certainty. Its lightweight hull spread its mass across wide tracks that refused to sink, a design first honed in the earliest members of the Weasel family. It wasn't the prettiest contraption in the war, and it handled like an argument between a lawnmower and a toboggan. Yet without machines like this, whole units would have been stranded in the cold's merciless grip. The winter campaigns exposed a problem the Allied armies could not simply ignore. Snow, mud, and shattered ground formed barriers thicker than any enemy line, reducing half the motor pool to stranded ornaments. Supplies that should have rolled forward in hours instead took days, carried painfully by men who were already exhausted by the cold. Strategists realized that without a lightweight vehicle capable of moving where wheels failed, entire operations risked slowing to a crawl, sometimes literally. From the earliest reconnaissances in Norway and the Ardennes, the Allies witnessed the limits of conventional logistics under extreme terrain conditions. Tracks offered promise, but relied on mass. Tanks could move, yes, but only where their bulk allowed, and they consumed fuel at a rate no remote front could sustain. Engineers recognized that what they desperately needed was not a miniature tank, but a new category entirely, a snow-skimming, mud-dancing supply carrier built around footprint rather than armor. The Weasel family, still in its early developmental stages, appeared at precisely the moment the battlefield was demanding such an answer. 3 technical requirements quickly emerged. First, the vehicle had to exert exceptionally low ground pressure, low enough to glide over surfaces that collapsed under infantry boots. Second, it needed a reliable powertrain with enough torque to pull sledges or trailers without overheating in thin, bitter air. And third, it had to be small enough for airborne deployment, because some fronts were simply too remote for delivery by road or rail. These weren't optional luxuries. They were non-negotiable elements for survival in a theatre where weather had become the dominant combatant. Winter's hostility, however, produced another lesson. Crews needed a machine that would start in freezing temperatures without prolonged coaxing. Carburetors had to be shielded from icing, and ignition systems needed careful waterproofing to avoid misfires in melting snow. Logs from mountain units repeatedly mentioned that engines fought humidity as much as cold, leading engineers to refine insulation and adjust fuel-air mixtures. Without these adjustments, no amount of track length would keep such a machine mobile. Not surprisingly, field commanders welcomed the concept even before the first prototypes arrived. They were tired of improvising with half-broken motorcycles or overloaded mules. One officer reportedly said that if the next vehicle could float over slush, he'd take 10 immediately. It turned out the Weasel could do exactly that, making some staff officers look as though they'd accidentally predicted the future. Its blend of lightness, traction, and improbable stubbornness marked the beginning of a logistical shift that would reshape cold weather operations across multiple fronts. The concept behind the Weasel family began with a simple recognition. Terrain itself had become an adversary that demanded a specialised countermeasure. Rather than improving existing trucks or attempting to lighten armoured vehicles, the aim was to create something whose geometry and mechanics were shaped entirely around difficult ground rather than adapted to it. The idea placed mobility at the centre of the design in a way few wartime machines attempted, treating the landscape's worst features as the reference point rather than the obstacle. The earliest design briefs focused on movement across snowfields, swampy riverbanks, and debris-laden clearings that conventional drivetrains simply could not navigate. Engineers placed unusually strong emphasis on track surface area, aiming to distribute weight wide and long enough to prevent descent into soft terrain. This priority influenced everything, from hull length to suspension spacing, because the entire machine needed to stay above ground rather than fight through it. That principle later proved decisive in the evolution from early prototypes to the more refined M29 configuration. A second major influence shaped the vehicle's vision, the requirement for controlled handling on surfaces offering almost no friction. This led to internal debates about sprocket pitch, track grousers, and the balance between grip and glide. Tracks for the Weasel family were built with a hybrid pattern that allowed forward traction while avoiding deep bites that would bury the machine in powdery snow. Careful tuning produced a surprising characteristic. The Weasel could pivot with modest effort, despite having such a large footprint, a behavior that made it uniquely maneuverable in frozen or swamp-like conditions. A third design pillar emerged from the need to carry meaningful loads without dramatically increasing mass. The Weasel had to move equipment, ammunition, radio sets, medical supplies, and sometimes tow additional weight in sledges or cargo trailers. Achieving this required a lightweight hull that avoided unnecessary armor while still providing structural rigidity. Reinforcement ribs were integrated into the hull frame to prevent flexing across uneven surfaces, ensuring the suspension carried the load without inducing twist along the chassis. The guiding vision therefore blended practicality with a rare kind of terrain-first engineering, resulting in a machine whose purpose could almost be read from its silhouette. It was the sort of vehicle that looked as if it had been designed by someone who'd lost patience with winter and decided to outrun it instead. The clarity of that approach set the foundation for one of the most specialized mobility platforms of the wartime era. Manufacturing the Weasel family required a production approach that looked almost inverted when compared with typical wartime assembly lines. Instead of constructing heavily armored hulls demanding intense welding and thick plate shaping, the factories focused on lightweight fabrication, precision alignment, and a tight control over tolerances that directly influenced how the tracks behaved on soft ground. Everything about the process had to support the principle of low ground pressure, which meant the structure could not veer into unnecessary mass at any stage. At the heart of construction was the hull frame, built from pressed steel sections engineered to remain rigid without resorting to heavy reinforcement. Each section was jig-mounted to ensure exact dimensional consistency, because even a slight warp could translate into uneven track loading once the vehicle hit snow or marshland. This precision became even more important during the shift toward later members of the family, where refinements in suspension geometry demanded matching accuracy from the underlying frame. The powertrain installation introduced another layer of complexity. Studebaker's six-cylinder engine, although modest in weight, required exact positioning to maintain the vehicle's fore-aft balance. If mounted too far forward, the bow dipped and risked ploughing into soft surfaces. Too far aft, and the track grip changed character, making steering unnecessarily difficult. Mechanics working along the line aligned engine mounts, linkages, and cooling ducts to tolerances that were unusually strict for a mass-produced wartime vehicle, simply because imbalance would compromise the entire concept. Track assembly formed one of the most distinctive elements of the build. Each track was made from rubberized fabric, reinforced with metal cleats, linked together through hinge pins that allowed flexibility without sagging. These tracks had to remain supple in sub-zero temperatures, so the rubber compounds were selected to resist brittleness, an issue that plagued many other tracked vehicles in winter service. The joining process used heating elements to bond rubber sections before cleats were riveted on, creating a surface that behaved predictably even under constant flexing. Suspension components were aligned on roller beds to simulate ground contact during assembly. Differences as small as a few millimeters in bogey position or spring preload could alter glide characteristics on snow, so factories introduced progressive calibration checks throughout the line. This meticulous approach paid off. The Weasel family often displayed consistent behavior across different units, an advantage that came directly from its careful build process. Electrical wiring looms were routed with deliberate spacing to avoid moisture traps, because condensation could form inside the hull whenever the vehicle transitioned from cold to warmer environments. Waterproof connectors and shielded ignition elements became standard, reflecting the reality that the Weasel would often operate in slush, spray, or meltwater. It was one of the few wartime machines whose electrics seemed designed by someone who assumed it would be drenched before breakfast. That pragmatic mindset made the family unusually resilient for a vehicle so small and lightly constructed. The final assembly stage brought together hull, suspension, tracks, and drivetrain in a sequence that left little room for improvisation. Once complete, each machine underwent a rolling bench test where its tracks ran on drum rigs to verify alignment and responsiveness. Only after passing this mechanical rehearsal was the vehicle prepared for shipment to testing grounds, where its unusual qualities could be examined under real conditions. Testing the M29 Weasel placed the vehicle in environments chosen specifically to expose its weaknesses, because no amount of design insight mattered unless the machine could survive the unforgiving conditions it was intended to master. Snowfields, ice crusts, thawing riverbanks, and churned winter mud formed a gauntlet of surfaces that punished any imbalance in track pressure or engine responsiveness. The aim was not to prove the Weasel comfortable on these terrains, but to prove it capable when nothing else was. One of the most distinctive behaviors observed during these trials came from the way its weight spread across its long, flexible tracks. On hard snow crust, the M29 skipped across the surface with surprising consistency, distributing mass so evenly that the hull left only a faint impression behind it. Yet, on soft snow or slush, the entire machine settled deeper before stabilizing on its broad track base, a counterintuitive behavior that prevented vertical sink and kept propulsion steady. This dynamic response stemmed from the careful matching of track width to suspension spacing, allowing each bogie to share the burden without forming a single point of collapse. Cold weather operation revealed new mechanical insights. The carburetor needed a stable fuel-air mixture even during sudden temperature drops, so testing teams experimented with revised intake geometry and shielding to prevent icing. Meanwhile, lubricants thickened rapidly in severe cold, affecting steering linkages and track tensioners, leading to a refined selection of oils and greases tailored for sub-zero responsiveness. These adjustments made the M29 notably more predictable in terrain, where other vehicles struggled simply to maintain forward motion. The braking system produced another challenge. On icy ground, mechanical brakes that performed well on solid earth became abrupt, forcing evaluators to adjust linkage tension and drum tolerances to deliver more progressive control. The Weasel's ability to pivot using track speed differentials proved valuable here, because partial steering input often produced safer, more stable direction changes than relying on brakes alone. This characteristic later became one of the vehicle's defining advantages in Arctic and subarctic operations. Load testing formed the final major evaluation stage. The M29 was required to carry cargo across uneven frozen surfaces without inducing excessive chassis flex or bogie distortion. Observations showed that its internal reinforcement ribs performed effectively, preventing torsion even when the machine traversed deep side slopes. Tow trials demonstrated that the Weasel could pull sledges and equipment far heavier than its own mass without overtaxing its drivetrain. a capability achieved through its torque-friendly gearing and lightweight construction. What emerged from these tests was a machine that behaved less like a small track truck and more like a terrain specialist built for surfaces that defeated conventional logic. Its handling in winter conditions was so unusual that mechanical reports read like notes from a vehicle determined to defy gravity out of stubbornness. The M29's trial performance confirmed that it could travel where wheels, hooves, and even many larger tracked vehicles faltered, proving its suitability for the demanding logistical roles awaiting it in active operations. Operational deployment placed the M29 Weasel directly into the logistical bloodstream of winter warfare, revealing both its unexpected strengths and the limitations inherent in such a specialised machine. When the first units entered snow-choked routes, the vehicle achieved what conventional transports could not: consistent mobility across surfaces that shifted unpredictably between powder, crust, and thawing slush. This immediate breakthrough transformed its role from experimental carrier to dependable link between frontline positions and support nodes that risked isolation without such mobility. One of the earliest operational consequences came from the M29's ability to maintain traction even with heavy cargo loads. Its broad tracks prevented sinkage during resupply missions, allowing medical equipment, ammunition, and rations to move across terrain previously marked as impassable. This capability reduced dependence on manual carriage during critical operations, freeing manpower for tasks that directly influenced frontline effectiveness. The Weasel thus enabled a more stable flow of essential material into sectors where resupply corridors were chronically disrupted by weather and ground collapse. However, the M29 did experience mechanical vulnerabilities when placed under continuous strain. Dampness created by thawing conditions could infiltrate track pins, leading to occasional stiffness and requiring more regular lubrication cycles than initially estimated. Similarly, extended towing of loads heavier than the recommended limit put stress on drivetrain components, demonstrating that the vehicle's strengths lay in mobility rather than brute hauling power. These shortcomings did not undermine its value, but they required operational planners to factor maintenance intervals more carefully into their scheduling. The amphibious M29C variant introduced a new dimension by adding flotation tanks and rudders, enabling water crossings under suitable conditions. While not a high-performance amphibian, it offered a practical ability to navigate shallow or broken waterways without requiring bridges or pontoons. This adaptation proved particularly relevant in areas where spring melt turned narrow channels into logistical barriers. The capability broadened the Weasel's operational utility, showing how its core design could be expanded without compromising its fundamental focus on low ground pressure mobility. Terrain transitions created another revealing test. Moving from snowfields onto rocky or firm soil required careful throttle application to prevent track wear, and operators quickly learned that the vehicle performed best when routes kept it within its intended environmental domain. The M29's strengths lay in surfaces where its weight distribution countered the landscape's instability. On hard ground, it functioned adequately, but without the remarkable efficiency seen in frozen or saturated environments. This division underscored the importance of assigning the Weasel to missions that aligned with its defining design philosophy. Despite its limitations, the M29 achieved a notable breakthrough. It allowed operations to continue seamlessly through weather cycles that would otherwise halt movement entirely. It demonstrated that mobility in winter did not require mass or armour, just a machine stubborn enough to treat snow like an inconvenient suggestion. The M29's mixed record of strengths and constraints solidified its reputation as a specialist platform that delivered precisely what was promised in the environments it was built to conquer. The introduction of the M29 Weasel carried implications that extended far beyond its immediate logistical role, influencing how armies approached mobility planning in environments previously considered too unstable for mechanized movement. One of the most significant hidden consequences emerged in the way supply chains were reorganized to incorporate lightweight tracked carriers as standard components rather than emergency improvisations. By enabling consistent movement across deep snow and saturated ground, the M29 reduced reliance on weather-dependent transport corridors and allowed planners to create routes that previously existed only on paper. This shift brought a new level of flexibility to cold region operations. Instead of concentrating supplies at large depots near stable roads, armies could distribute stockpiles across multiple satellite points connected by Weasel-ready paths. This decentralization improved resilience because temporary closures caused by drift formation or freeze-thaw cycles no longer threatened the entire logistical system. The M29 effectively altered the geography of resupply, turning inhospitable surfaces into functional lanes that supported sustained operations even during severe environmental cycles. Beyond logistics, the M29's capabilities produced quieter, less publicized effects in technical doctrine. Its success highlighted the value of designing equipment around environmental extremes rather than adapting general-purpose vehicles to multiple conditions. This principle encouraged further research into mobility platforms tailored for deserts, wetlands, and Arctic regions, leading to doctrines that treated terrain as an engineering variable rather than an obstacle to be bulldozed or bypassed. The Weasel's example thus contributed to a broader shift in thinking about terrain-specific machinery across both military and scientific fields. A further impact emerged in rescue and evacuation procedures. The M29's predictable tread behavior on unstable surfaces allowed medical teams to reach casualties in locations where traditional vehicles stalled or risked overturning. This capability proved particularly valuable during periods of rapid melt, when ground transitioned unpredictably between firmness and collapse. Lightweight construction, steady torque, and stable center of gravity combined to produce a platform that could transport wounded personnel without excessive vibration or jarring, a feature that supported higher survival rates in remote or weather-challenged conditions. In scientific expeditions, the same characteristics encouraged polar researchers to employ the M29 for the movement of instruments, food stocks, and technical gear across ice shelves. Its ability to operate reliably in isolated environments allowed teams to conduct studies deeper into the polar regions than earlier transport methods permitted. This cross-sector adoption demonstrated how a wartime design could find a second life in research contexts, influencing fieldwork methods long after the conflict ended. The cumulative effect of these changes was subtle, yet profound. A small vehicle originally conceived for a specific wartime role ended up reshaping mobility across multiple disciplines. It proved that specialized engineering, when aligned precisely with environmental demand, could produce outcomes far beyond its intended mission, even if the machine itself looked as though it had been sketched during a moment of mechanical impatience. The M29's hidden contributions lay not only in what it carried, but in the new ways it allowed people to think about movement across the world's harshest terrains. In the years that followed its wartime service, the M29 Weasel entered a new phase defined not by conflict, but by adaptation. Its lightweight construction and low ground pressure performance brought it naturally into the world of polar exploration, where the qualities that once supported frontline logistics now enabled researchers to push deeper into remote ice fields. Survey teams valued the Weasel for its predictable handling on snow bridges and its ability to traverse low-friction surfaces without the destructive sink common to heavier tracked vehicles. One of the most enduring post-war uses appeared in national Antarctic programs. The M29's hybrid of stability and maneuverability made it an ideal support vehicle for transporting meteorological instruments, drilling equipment, food stocks, and prefabricated shelters across terrain that shifted daily beneath the wind's pressure. Its capacity to maintain propulsion over sastrugi, pressure ridges, and soft, wind-scoured patches gave field parties a dependable means of reaching outposts that lacked prepared runways or compacted paths. This reliability shaped the practices of early polar stations, influencing how engineers planned field camps and remote supply sequences. The vehicle's mechanical layout also attracted attention from designers of future snow-capable transports. The importance of track length relative to chassis size, the balance of weight distribution, and the interplay between sprocket geometry and snow adhesion became reference models for later cold environment vehicles. More advanced polar carriers borrowed elements of the M29's design philosophy: broad tracks to reduce ground pressure, simplified drivetrains for easier field repair, and hull structures that prioritized rigidity without unnecessary mass. These concepts persisted into snow tractors, scientific crawlers, and even modern tourist expedition vehicles. The M29's amphibious adaptation, originally created to support riverine and coastal operations, found renewed relevance in regions where ice sheets fractured seasonally. The M29C's flotation elements influenced later thinking on dual-domain mobility, encouraging research into platforms that could transition seamlessly between ice, water, and semi-frozen coastal terrain. This continuity of design thinking demonstrated the unexpected longevity of a vehicle born from wartime necessity, but sustained by peacetime innovation. Restoration enthusiasts later revived many surviving Weasels, favouring the model for its mechanical simplicity and the clear logic behind its engineering choices. The vehicle's construction allowed components to be refurbished without specialised equipment, while its modest weight made transportation and maintenance achievable with limited workshop infrastructure. This accessibility contributed to its presence in collections, demonstrations, and research support roles long after more complex wartime vehicles had become impractical to operate regularly. Across all these developments, the M29's legacy settled into a distinct category: a machine that redefined mobility in environments governed by cold, instability, and low friction. Its post-war career showed that a design originally aimed at overcoming battlefield obstacles could continue to solve problems in far quieter places, often with the same determination it once displayed during the harshest months of the conflict. Its influence endured not through spectacle, but through a consistent demonstration that the right engineering can turn even the most treacherous surfaces into navigable ground. The image of the M29 Weasel gliding across frozen ground lingers because it represents a rare intersection of engineering focus and environmental necessity. From the first trials in snow-choked theatres to its later service in remote scientific outposts, the machine demonstrated how a clear design purpose can cut through the challenges of hostile terrain. Its movements were never graceful, but they were consistent, and in cold regions, consistency mattered more than speed or elegance. That reliability forms the backdrop to any reflection on what the M29 ultimately achieved. Terrain had always been an adversary in warfare, yet the Weasel approached the problem without attempting to overpower it. Instead, its low ground pressure, broad tracks and balanced hull worked with the landscape's instability, distributing forces in a way that allowed progress where other vehicles failed. This cooperation with the environment, rather than domination of it, became a defining feature of its design philosophy. The M29 showed that success in extreme conditions often comes from understanding what the terrain will tolerate rather than what engineers wish it could endure. The machine also reshaped expectations about what a small, lightly built vehicle could accomplish. In theatres where larger transports stalled, the Weasel demonstrated that mobility sometimes depends more on physics than horsepower. Its ability to carry meaningful loads across fragile surfaces came from engineering choices that favoured surface contact area and engine tractability over raw output. These principles continue to echo in the design of modern low-impact Arctic vehicles, where minimising ground disturbance remains a primary objective for both environmental and operational reasons. Even in regions far removed from its original battlegrounds, the Weasel left a quiet yet unmistakable influence. Mountain expeditions, polar surveys, and remote maintenance crews learned to adapt their work patterns to the capabilities of small tracked platforms built in the spirit of the M29. The vehicle's emphasis on balancing mass and traction became a reference point for those designing equipment for terrain too delicate for heavy machinery and too demanding for wheeled solutions. It offered a template for movement in places where surface instability shaped every decision. Looking back, the M29's significance rests not in spectacle, but in the clarity of its mechanics. It solved a narrow but vital problem by accepting the realities of snow, slush, and meltwater, rather than attempting to fight them with excess power or armour. It behaved like a machine designed by someone who had finally decided that if winter could not be beaten, it could at least be crossed with a measure of mechanical dignity. What remains is the simple, factual truth that the M29 Weasel enabled movement where the landscape seemed intent on denying it, and that achievement stands firmly within the history of vehicles built to conquer the world's coldest ground.